But thank you all for being here on time. While we get started, we are going to join this pair deck. So in order to do that, you'll go to joinpd.com. All right, so joinpd.com, and then you enter the code, which is on the top right of your screen. So AUCCND. So go ahead and do that so that you can interact and answer questions as we go. All right, but hopefully you all have been navigating the end of the course okay. If you have any questions at this time, while we wait for everyone to join the pair deck, now would be a good time, or if you just want to throw them in the chat or wait till the end, that is fine too. All right, let's see. I don't know where to see how many have joined the pair deck. Hopefully you guys are finding it okay. I think I might have to rewrite this somewhere else. Okay, there we go. So you'll go to joinpd.com and you will enter this code that is over here to join our presentation. All right, and while you guys are doing that, and here I'll even write the code. I mean, the code should stay there, but I'll just rewrite it here just in case. AUCCND. Just a couple general announcements. I kind of always start the same each class. And first we start with the PACE calendar. So today is the 23rd. When I was looking at it yesterday, it was the 22nd. So that's why I included day 16. But really, you should be submitting your day 17 daily ALEX assignment, assuming that you are that far. Some of you are a little bit behind. So remember that it's all based on your goal. So if your goal is 10 topics per day, well, for every 10 topics, you submit another daily assignment. So keep that in mind. You might actually be on day 13 that you're turning in, or you might even be ahead. It all just depends on your goal. So make sure you're following that up. I know some of you have learned all your topics and you're like, I don't have any more topics to learn, but I still have daily ALEX assignments to complete. Just always kind of verify with me. Some of you have already, which is great. I'll make sure that you've submitted enough daily ALEX assignments. And then for the remaining ones, I'll have you submit basically just like a sentence saying that you master those through the progress check. But I do need to check those first to make sure that you truly are finished with all your topics and you don't have any more ALEX assignments to turn in before you do that. All right. And then today you should also be completing the similarity reflection in Canvas and responding to 2 other people. So make sure that gets taken care of today. And then of course, keep following the PACE calendar as best you can. The next thing that's coming up on the PACE calendar is our Unit E test. So that is what we are going to spend time reviewing today. All right, and just a few gentle reminders. If you have not done your second DBA, you may have it scheduled today or tomorrow. If you don't, you need to schedule it preferably today or tomorrow. We don't really want to carry it into next week since the course ends on the 29th, and that is a Wednesday. So we really don't want to be carrying the second DBA into next week. Of course, if you're completely unavailable, you know, we need to get that done to give you credit for the course. So get those done sooner than later. You can schedule it through this link. And this slideshow is also in Canvas on our course homepage. So if you want these and you want to click the link from there, that would be a good idea. But yeah, schedule those as soon as possible. Make sure that you are keeping up with your grades, keeping up with your missing assignments, because again, the course end date is near. All right, so now on to the real lesson. And first we're gonna start with ratios. So ratios kind of tell you how much, like say we have a mixture of something, we usually will use a lot of examples that have like recipes. It's kind of like how much of a mixture is this. So say like for every 2 parts water, we add 1 part flour. All right, well, in that case, how many parts do you have total? Well, I have 3 parts, just 2 of them are water and 1 of them is flour. So those come into play in this lesson, which is mostly about similarity. All right, but in this particular example, there are 8 roses in a vase of 13 flowers. The rest are daisies. So it says, what is the ratio of daisies to roses? All right, so you have to specifically look at what they are asking. So go ahead and maybe for this one, you can type in the chat. Or if you'd like to draw on this slide, feel free. But what do you think the ratio is of daisies to roses in this problem? All right, so we have similar answers in the chat. Feel free to submit your response still, either in the chat. Let's see if anyone submitted it through Pear Deck. And again, these are anonymous, so don't feel like you want to like erase your answer. All right, but we kind of have a variety of answers. So let's remember first that even though it gave us the order of 8 roses and then out of like, you know, the 13, the rest are daisies, make sure that if it wants a ratio in a certain order, like daisies to roses, well, I want the number of daisies first. So if there are 8 roses out of 13 flowers, the rest are daisies. All of you seem to get this part right. Well, then that means that 5 of them are daisies. So that number should be first. All right, and ratios we can represent with a colon or a fraction. Colon is what the majority of you entered it as. So the ratio of daisies to roses, well, since there's 8 roses, would be this. Now, don't get it confused. Don't assume that even though, yeah, we can write ratios as a fraction, that the equivalent of this ratio is 5/8. All right, do not do that. And I made that mistake a long time too, until a professor in college told me when we were in chemistry and we were making mixtures of things. It was something to the effect of, and I'll use kind of this as an example, for every 5 parts of chemical 1, add 8 parts of chemical 2. And so I was thinking, okay, so there's 8 parts total, when really there's not. There's 13 parts. So if you wrote this as a fraction and you were trying to show like daisies would be 5 out of the 13 of the flowers. Roses are 8 out of the 13 of the flowers. All right, but to write it as a ratio, it is this. This is our final answer. But the equivalent fractions would be this. Questions about that part? All right, now go ahead and answer part B, and this time I will specify use a colon this time, so that dot. What is the ratio of daisies to all flowers in the vase? Either type it in the chat, write it in the pear deck. We'll show both. All right, now let's see our responses. Ignore my annotations. In fact, I'll clear them. All right, good. So it looks like we are all on the same page for this problem then. The answer is 5:13. And again, just pay careful attention to what they're saying. Daisies to all flowers. Well, we determined that there was 5 daisies, and out of all flowers, there's 13 total. So kind of think at that colon as like saying the word two. So 5 to 13. Good. So next part. And you'll see why this all comes into play with similarity here in a second. But for this one, we're going to solve for u. All right, we've set up a couple proportions. So take some time, solve for u. Maybe don't put it in the chat yet. But if you're writing it on your own screen, you know, go ahead. Solve for u. All right, so those of you typing your answers in the chat, feel free to enter it now. What is the value of u? Everyone else, I'm going to show your responses. All right, and then the responses for the pear deck, it looks like we're all on the same page. The answer, you all figured it out. Everyone that's answered so far is 8. So good job. There was 1 or 2 of you that didn't respond. So for those 1 or 2 of you, here's how you break down that problem. So proportions are some of my favorite things. Basically, we're saying that this fraction is equal to this one. Well, when you set it up like this and you just have one variable to solve for, you can do that easily by doing cross multiplication. So 12 times 6 and then 9 times u. All right, 12 times 6 is 72. And then when solving for u, do the opposite of what's being done. So instead of multiplying by 9, I'll divide that. Whatever you do on one side, you have to do to the other. And we get that u is equal to 8, which everyone who did respond did get that correct. So good job. All right, so next problem. Joe works for 15 hours and earns $330. If Joe works for 21 hours, how much does he earn? So go ahead and try this one out. Feel free to put your response in the pear deck, but if you're typing it in the chat, kind of hold your response in your head for a little bit. I'll give you about 30 seconds to try this one. All right, and the 30 seconds are up. All right, and just in case you are just entering, we're glad you're here, by the way. But we are on joinpd.com, and once you're in there, you will enter this class code. All right, but let's see if you have your answer in the chat. Go ahead and press enter now. And then everyone else, I'll show your responses. We even have some work shown. Good, and I'm gonna go back on this one that has it kind of broken down for you, or at least almost all the way. This one is good too. So first thing you'll want to do is set up your proportion and always set it up consistently. There are some variances you can have, but just keep it consistent no matter what you do. So in this one, if you did like hours worked over pay, then make sure that the other fraction on the other side is also the hours worked over pay. All right, because then if you mix match it, you will not get the right answer. You are welcome to, if you wanted to, set it up as pay over hours worked. You can do that as well. Because when you cross multiply, you should get the same equation. So like you should have gone 15 times x, and let me use a better color than that. And then 330 times 21, which on my calculator, I got 6,930. Solving for x, dividing each side by 15. And that's where, and so far everyone that's answered got it right. $462 is how much this person makes in 21 hours. So see, there is some variance in how you set up your proportion. Just keep it consistent. If you have hours over pay, make sure the other fraction is also hours over pay. If you have pay over hours, make sure the other fraction matches up. Questions so far? All right. If you do, just feel free to throw them in the chat and I'll make sure to address them. And let's see, I thought I had some pictures before we got to here. Maybe it's after these ones. All right, but here's our next problem. And this one, I kind of don't expect you to know right away unless you've already learned this unit in Alex. So I'll walk you through this one. But we have segment AB is equal to 35. A point C lies on segment AB. So let's draw a visual. Visuals always help. All right, so, and I don't know what direction it really is going. All right, so let's just say this is A and this is B. And we have a point C, and I'm not drawing this to scale, that lies on segment AB and partitions AB into the ratio 2:3. So that means it's, and if we set this up as a fraction, 2:3, think of like how many parts is there then on the line from A to B? Is it 2 parts? Is it 3 parts? Is it some other number? How many parts total do we have? Good, thank you, Jacob. So remember that when you have ratios like 2:3, that's really 5 parts. That's like saying 2 parts water for every 3 parts flour or something like that. In this case, we actually have 5 parts to this line, and C lies, I guess, from A 2/5 away from A and like 3/5 away from B, if that makes sense. So we need to find the lengths of segments AC and CB. So in that case, since I have 5 parts, right, because 2 plus 3 is 5, and since AB, the whole line, equals 35, well then I'll do 35 divided by the 5 parts to kind of tell me the length of each part. So each part has a length of 7. So I'm just going to kind of roughly sketch this. Again, not drawn to scale. So there's 1, 2, 3, 4, now 5 parts. Each one has a length of 7, which adds up to the whole length of 35. So C would be here, right? Let me just verify on my notes. Yep, C would be here because it's 2 to 3, 2 to the right, 3 to the left. And think now, what's the length of AC and what's the length of CB? So go ahead and either write that on your Pear Deck, the answer, or type it in the chat, but maybe don't press enter yet. Think of what our lengths of AC equal and what our lengths of CB equal. All right, and then if you typed it in the chat, you can go ahead and press enter now. All right, I'm going to clear my drawings and we'll see what some of you said. All right, and I even like your guys' drawings as well. But yeah, AC is 14, and it doesn't give us units, but it's 14 units long. And then CB is 21 units long, because if you remember, each unit or each part has a length of 7. So if I have 2 parts here, well, they add up to 14. If I have 3 parts here, each a length of 7, then they add up to 21. So all that have answered are correct. So good job. All right, let's see the next problem. All right, so more partitioning a line segment. This time we have coordinates. So those can be a little bit confusing. You just kind of have to really think about where you're moving and by how much. So first we have the point N lies on segment MP as drawn. We have coordinates for M and P, but we need to find the coordinates of N so that the ratio of MN to NP is 3 to 2. So imagine we have 3 parts over here and just 2 parts on the other side. So in that case, we do need to look at where the X and Y is moving from M to P. All right, and then we can separate it out into sections, because right now we don't know what the length of each section will be. We just know how many parts there will be. So in that case, think about the movement in the X value from M to P. How much did the X value change, going from -13 to a +2? Go ahead and type that in the chat. All right, so we're looking at the movement from the X value of M to the X value of P so that we can get the full movement. All right, and thank you, Jacob. It is 15 to the right. When you go to the right on a number line, think, are my numbers positive or negative? So when I move to the right, I'm basically adding 15. Now, we also need to keep track of the Y movement. So what is the Y value change from M to P? So going from 18 to -7, that Y value movement. All right, there is a difference of 25. And think like, where is it moving, up or down? And when we go down on a coordinate plane, think, what does that do to the number? Does it make it positive or negative? All right, so what that does when we move downward on a coordinate plane makes it negative. So we're gonna put a negative on there. So, and it moves down. All right, but just know that that downward movement makes it a negative on the Y. All right, so now that we've kept track of that, and we know that when we are partitioning a line so that the ratio is 3:2, we saw that in the last problem too, that there's 5 parts total. So in that case, you're basically going to take each of the movements you just kept track of, like the 15, and you're going to divide it by the number of parts. So 15 divided by 5 is 3. All right, and then think of how many parts I am moving to get to the n of, or the x of my n coordinate. So that's 3, 6, 9. So take that original x, which was -13. We're going to add 9 since we're moving basically 3 lengths of 3 to the new x value. -13 plus 9 is -4. So right now I know that the x of my coordinate n is -4. Now using that same logic, try and find the new value of y. Feel free to type it in the chat, but don't press enter yet. All right, so take the movement in the y value, divide it by the number of parts, and then calculate where the new y would be for the coordinate n. All right, now go ahead, and if you typed your answer in the chat, you can press enter now. We'll see some responses on here as well. All right, watch those X's and Y's. Make sure it goes in the order X, Y. All right, we have a mixture of answers. So let's see. And sorry, I had to erase my work. But what we did to find the value of X, we did 15 divided by the number of parts, which is 3. And since we want the ratio to be 3:2, we know that the X is moving down or to the right 3, 6, 9 away from 13. So if we add 9, since we're moving to the right, we get -4 for the X. We already had that part. For the Y, we said that the movement was -25 because we moved downward, divided by the 5 parts. So negative 25 divided by 5 is negative 5. So, and again, since we're going from m to n, we're going down negative 5, negative 10, negative 15. All right, my y originally was 18. So if I do 18, and since we're going down, that's minus 15. We get our new y value of 3. So some of you had it, maybe it was just in the incorrect order. Make sure that your final answer is in the coordinate x, y. All right. Questions, comments, concerns on this one? If you made a mistake, do you know what you did wrong? All right, so let's see what the next one is. All right, and actually, before we get into the next set of problems, I do have like some definitions for you. I don't necessarily want to spend too much time of our live lesson of you writing them down. So again, this whole slideshow is in the course in Canvas. So just go to today's date, click on the slides, and feel free to copy those if you want, or however you take notes, if you just print them, if you take pictures. These next slides are going to be some of the theorems or postulates that you need to know for similarity of shapes. So in this one, and we're referring to triangles, the side angle side similarity postulate. Now, if that sounds familiar, there is a side angle side congruency postulate. But remember the difference between similarity and congruency. Things that are similar have same angles. So I'll write this off to the side. Things that are similar have identical angles, but then proportional sides. Meaning that not only are the sides just like different values, but they're all basically multiplied by the same number. That's what proportional means. Like if I were to dilate this triangle, like in this example, to be 2 times bigger than the original, then I would multiply each side by 2. So like 5 times 2 gives me 10. 3 times 2 gives me 6. So in that case, if we knew whatever side this was, maybe this side is x, well, then this side would have to be 2x. So if all of the sides are multiplied by the same number, essentially, or you can even think like divided by the same number if it's getting smaller, then they are proportional. And the angles have to be identical as well. So for the side angle side similarity postulate, this one says that if 2 or more triangles have a corresponding congruent angles and the sides that make up these angles are proportional, then the triangles are similar. So again, they're not congruent. So I don't want to put like tick marks to make you think that they're congruent. But the sides that surround the identical angle are proportional to each other. Same with this side. This side is proportional to this corresponding side. And then the angle that's between them is congruent. So that would be our side, angle, side, and then specify it's the similarity postulate now. All right, the next ones I'll go through a little bit faster, but just really wanted to make clear what similar means, identical angles, proportional sides, and now let's go through the postulates. All right, so we also have the side similarity postulate. So maybe you don't know what the angles are, but you have that all the sides are proportional. And if I was going from this small triangle to this big triangle, what number am I multiplying each side by to get the bigger triangle? Good. Thank you, Joshua. It is 4. All right. So like to get the hypotenuse of the other one, 4 times 4 is 16. To get the smallest side, 4 times 2 is 8. The base, 4 times 3 is 12. So since I'm multiplying the same number on each side, they are proportional, meaning, and then since it's 3 sides that are proportional, that's the side similarity postulate. All right, we also have the angle similarity postulate. Now this one's interesting because it's just 2 parts of the triangle that we're looking at. But if you think about it, when we have 2 triangles that have 2 identical angles, well, then the other one must be identical to the other one that remains on the other triangle, right? Because all triangles add up to how many degrees? All right, 180 degrees. Good. Thank you, Lulu. So if I were to, find the measure of angle C and angle F, well, I'm doing 180 minus 83 minus 63. And then when I go to do it for this bigger triangle, I subtract the angles. And look, I have the same problem being done. So even just knowing only 2 of the angles, I don't necessarily even have to solve for the third one because I know it's going to be the same. But just for fun, I'll just do it real quick. 180 minus 83 minus 63 is 34. All right, but really all you need is the 2 congruent corresponding angles. So they do have to be in the same parts of both triangles. But yeah, once you do that, then you know that they're similar through the angle similarity postulate. And then remember, just kind of a side note here, that order is important. A lot of the times you can read a problem and know what point corresponds with what other point on the other triangle. And that is very helpful because it's not always easy to match it up when one of them is like rotated in a weird position to see which side actually corresponds with the other side. So just always know that order matters. So if I said triangle ABC is similar, so similar uses that squiggly line, that's not the same as saying triangle ABC is similar to triangle DFE. All right, order matters. There's also this theorem that might be helpful to you, the triangle proportionality theorem, which says that if a line is parallel to one side of a triangle and also intersects the 2 other sides, the line divides the sides proportionally. So in that case, DE would be proportional to BC and so forth. All right, so let's do a few problems now that we know that. So I have 2 triangles below are similar. And again, here's those details that I told you about that are super helpful. When it tells you that triangle ECD is similar to triangle XYW. One thing I've even started to do is kind of just line them up on top of each other. ECD is similar to XYW. And then that way I know like, okay, this corresponds to that, this corresponds to that, and so forth. So when it says the measure of angle E is 65 degrees, well, since that corresponds with angle X, I could also label angle X as 65 degrees. Remember that the angles of similar shapes are identical. And then it says the measure of angle D is 85. So which other angle on the other triangle is also 85 degrees? Is it Y or W? That is 85 degrees. Good, it is W. And then again, this little drawing over here that I drew helps me figure that out if it's not easily seen. So since the D is listed third and the W is listed third, they have the same angle. So this one is 85 degrees as well. All right, and the problem is asking us to find the measure of angle W, which we did already find. Just from knowing that order matters, that this corresponds to this angle. We need to find the measure of angle X, which we also know because of the same reason, it corresponds with angle E, so it should have the same measure. But now we also need to find the measure of angle Y. I'll give you guys 30 seconds to find the measure of angle Y. Don't hit enter yet in the chat if you're typing it in the chat, but find the measure of angle Y. All right, and the 30 seconds are up. So go ahead and press enter now if you typed it in the chat. I'm gonna pull up, see if anyone had some responses, which we do. All right, and it looks like of all the people that have answered, we are on the same page. Now, not everyone has answered, so let's work it out. All right, in order to finish solving this, you had to remember that triangles add up to 180 degrees. So if I subtract the other two angles, so 65 minus 85, that is how I get the correct answer of 30 degrees for my angle Y. All right, angle C is also 30 degrees since it corresponds with angle Y on these similar triangles. So good. Let's see the next one. All right, this time we have quadrilaterals that are similar. And again, order matters. If you kind of want to take some time and line them up, I think that that's helpful. A, B, C, D is similar to P, Q, R, and S. All right, this one, maybe you didn't need to do that because these are already in the same orientation. But if one of them was like rotated, you can just look at the problem and figure out what corresponds with what. But we need to find the length of SP, all right, which is labeled with a variable. Find the corresponding side on the other shape. And since it's SP, well, then the corresponding side would be DA, this side. And just like we did in the first problems, we can solve for X by setting up a proportion. So go ahead and set it up. Usually I set it up like the left shape above the right shape, kind of like how we read. So I might set it up as 5 over X, but feel free to do X over 5 if you want. Just make sure whatever you do, you keep it consistent. And I'm going to want to make this equal to a fraction that has both numbers in there, since I already have a variable. In order to solve for the variable, I need to have two numbers over here. So think about what fraction this can be equal to. And then go ahead and type it in the chat. There's more than one right answer. So go ahead and tell me what other fraction it could be equal to. so that we can solve for x. Let's see. All right, here's one of the right answers. I could choose to do these two corresponding sides. And since I set it up as the left shape over the right shape, so 5 over x, then I have to keep that consistent. If I chose that side, then I would do 3 over 3.6. You could have also chosen to do 2 over 2.4, 4 over 4.8. Just keep it consistent to however you set it up initially. And now that I just have the one variable in my proportion, I'm gonna cross multiply and solve for x. So the way that I set it up, I have 3 times x, which is 3x, and 5 times 3.6, which is 18. Opposite of multiplying by 3 would be to divide by 3. And we get x equals 6. All right, so set up your proportion, find corresponding sides, and solve for the missing variable. All right, just seeing if anyone else wrote some stuff down. But yeah, you are correct. See the next one. And again, just as you have questions, feel free to throw them in the chat. All right, so now we have similar right triangles and we need to find the length of x. This time it doesn't give us the order, but because it's a right triangle, those are a little bit easier to see the orientation. If you need to like redraw it so that they are in the correct or in the same orientation, go ahead. All right, like maybe if I was struggling, I would redraw it so that they're in the same orientation. And then set up your proportion. I just do it like left to right. So I would set it up as 2.5 over 5 equal to 3 over x. So if you do small triangle over big triangle, then make sure the other fraction is also small over big. And make sure that the fractions themselves are for the same corresponding side. So like the height is this fraction over here. The base is this fraction over here. All right, now you guys take it from here. Take about 30 seconds and solve for x. Don't hit enter yet though in the chat. Just take 30 seconds and solve for x. All right, go ahead and press enter now, and I will pull up some other responses. All right, so far everyone that has responded has said 6. Anyone disagree? All right, you are correct. So again, set up your proportion. Make sure you're keeping it consistent, however you set it up, and then cross multiply. So 5 times 3 is 15. 2.5 times x is 2.5x. Opposite of multiplying 2.5 is dividing 2.5. Throw that in the calculator and x is equal to 6. Good. I think we might have time for 1 or 2 more. So now we have indirect measurements. So basically a word problem. We have a pole, and let's kind of draw this out. Let's pretend this is my pole. That is 2.6 meters tall. And cast a shadow that is 1.07 meters long. At the same time, we have a nearby building that casts a shadow that is 40.25 meters long. So in this case, is it going to be drawn for the vertical line, the 40.25, or for the horizontal line, the 40.25? Right. So we have at the same time a nearby building casts a shadow that is 40.25 meters long. So will it be the vertical measurement or the horizontal measurement that they provided us? All right, the answer would be the horizontal measurement. Because if this right here represents the shadow, and then they gave us the measurement of the shadow, then it should be in the same location. And then we're told to solve for how tall the building is. So that's my unknown. That's what I can label as X. Another proportion type problem. So in this case, I would set up my proportion as 2.6 over X, small over big this time, equal to 1.07 over 40.25. From there, it is a cross multiplying problem. 40.25 times 2.6 is 104.65. Feel free to correct me if I'm wrong. Divide the 1.07 on each side of the equal sign, and X equals, and we're rounding to the nearest meter, 98 meters. All right, so that kind of takes up all the time that we have today. If you kind of want to stick around and ask questions, feel free. I'll just kind of flip through and see if there's any others I feel like we should go over, but you are dismissed. I always overplan, so that's why there's always a bunch left over that we didn't get to. But if there's a specific one you want to see, just let me know. Otherwise, have a great day, and feel free to keep messaging me as you have questions once you finish out, as you're finishing out the course. Thank you all for joining.